Hi guys, today in our channel we will be learning about math thing called sequence and series, which lead to limit. So let's get started. We divide the lesson into 5 simple sections for you to learn. What you should know is that you must complete each section respectively. If you already understood the previous sections, feel free to move on to the next. Divide the lesson into 5 simple sections for you to learn. What you should know is that you must complete each section respectively. If you already understood the previous sections, feel free to move on to the next.
Starting off with a thing called a sequence. In mathematics, a sequence is an enumerated collection of objects, in which repetitions are arranged in order matters. In our lesson, a sequence is classified into two types, which are an arithmetic and a geometric sequence. From the sequence that is given, this is called an arithmetic sequence, or a sequence that is added or subtracted by a common number in each term. Can you tell what number comes next? Yes, I can hear that, 17. How do you know that? Because this term is added by 4, right? You can see that the first term is less than the second term by 4. So x sub 5 is x sub 4 plus 4. So we get 17. We call the 4 a D, or a common difference. Now, this is an example of a geometric sequence, or a sequence that is multiplied or divided by a common number. Look at this sequence. Can you tell what is the next term? You can see that each term is multiplied by 2. So for a sub 5 is a sub 4 times 2. So we get 16 times 2. So a sub 5 is 32. We call it 2 and R, or a common ratio. But what if I want to find the 99 term of this sequence? Do I need to keep adding them up? No, we don't need to. There is an easier way for that. We have the formulas for the n term of these two types of sequence. The formula of a arithmetic sequence is the first term plus n minus 1 times d, and the formula of a geometric sequence is the first term times r to the power of n minus 1.
Determine the sequence is arithmetic, find the common difference, and a sub 9s. So this is the sequence 1, 5, 9, 13. So for arithmetic sequence, we have to use the formula a sub n equals first term plus n minus 1 times d. So we know that the first term is 1, as you can see, and n is what you're finding, the term that you want to find. So n in this question is 9, and d for the common difference. Common difference is the second term minus by first term, so it's 5 minus 1 equals 4. So when you substitute all of it in, you will get the first line, which is a sub 9s equals 1 plus 9 minus 1 times 4. So you get 1 plus 8 times 4, so a sub 9s equals 33. Now, what about a geometric sequence? So find the common ratio and a sub 9s for this sequence, 2, 4, 8, 16. So we use the formula for the geometric sequence, which is a sub n's equal first term times r to the n minus 1. The first term is 2, as you can see. N, or the term you want to find, is 9, so n equals 9. R, or the common ratio, is the second term divided by the first term, so you get 4 over 2, so r is 2. Now substitute all of it in the equation, so you get 2 times 2 to the 8, so a sub 9 equals 516.
In order to solve this problem, we have to know about sigma. Sigma is used for the summation notation in a Greek letter written like an E sign in the middle. Sn represents the summation of the series. Above the sigmas represent the last value of n. And at the bottom of the sigma represents the first value of n. And an represents the formula of the term. And to find the answer for this summation, we also have to know the formula. Here's the formula of the arithmetic series. There are two formulas. You can choose which formula you want to use by depending on what is being given in the questions. It might look weird, but let's go over it together.
Evaluate each arithmetic series described. So given the 20th term is 135 and the common difference is 7, find S of 30. So the arithmetic series formula is given to here. So S of n represents the sum of the n term, and the n represents how many n term will you be solving. So in order to solve this problem, you have to know the first term first. So you will be using the arithmetic sequence formula, which is an equals first term plus n minus 1 times d. So you substitute all the things you know in, which you will get 135 equal first term plus 19 times 7. And that will lead you to the first term equals 2. Now you know the first term. You can substitute it in the formula of the arithmetic series. So the variable for the first term is a sub 1. So this formula is a sub n equals n over 2 times parentheses 2 times first term plus n minus 1 times d. So as you substitute all the things in, you'll get S of 30 equal 30 over 2 parentheses 2 times 2 plus 30 minus 1 times d, 7. Now, when you calculate all of it, you will get 15 times 207. So the answer for S of 30 is 3105. Now let's try another problem. If arithmetic series is -1 plus 1 plus 3 plus 5 and keep adding, and S of n equals 360, or the sum of the n term equals 360, find n. So this is the formula for the arithmetic series. Now first thing first, you have to find the d, or the common difference. So d equals the second term minus by the first term. So you get 1 minus -1, which is 2. Now you can substitute all the variable in the arithmetic series formula. So you get 360 equals n over 2 times parentheses 2 times -1 plus n minus 1 times 2. So moving 2 from the n over 2 to multiply with the 360, you'll get 720 equals n times 2n minus 2. Now moving all the variable in a good shape, you'll get 2 times n squared minus 2n minus 720 equals 0. So finding and solving for n, you'll get 20 and -16. So n can be -16 as you plug in the number. And since n represents the n term of the sequence, so it can be a negative number. So n equals 20. Moving on to the geometric series formula. If r, or the common ratio, is greater than 1, you use the formula at the top left of the box. But if the r is less than 1, you use the bottom one. And another one is just regular, depending on what case you're solving. If geometric series is 1 minus 4 plus 16 minus 64, find S of 6. So you know the first term is 1, and n, or the n term for the sum, is 6. And r, or the common ratio, is the second term divided by the first term. So you get -4 over 1. So r equals -4. Since r is less than 1, you use this formula. So substituting all the variable you know in, you get S of 6 equals 1 times 1 minus 3 to the 6th over 1 minus negative 4. You'll calculate it and get 1 times negative 4095 over 5. So you get S of 6 equals negative 819. Determine the number of terms n and the common ratio in the geometric series that have the first term equal 3 and the a sub n equals 192 and s of n equals 381. So find common ratio first, since all the variables fit in the geometric series formula. So you'll get, after substituting, you'll get 381 equals 192 times r minus 3 over r minus 1. And moving and calculating, you'll get 189 r equals 378 and get r equals 2, which is the common difference for this geometric series. Now, find the n. Since you know that r is greater than 1, which is 2, now you use this geometric series formula to solve it. And substitute all the things you know n for this formula, and you'll get 381 equals 3 times 2 to the n minus 1 over 2 minus 1. Calculating things, and you get 128 equals 2 to the n. So you know that 128 equals 2 to the 7. So 2 to the 7 equals 2 to the n. So n equals 7.
Arithmetic sequence. First you have to find the common difference. When you minus the second term by the first term, that's your common difference. D, by the way, don't forget the formula. It's not to win, blah blah, but a sub n equals first term plus n minus 1 times d. OE and formula for the arithmetic series. There's two of them you have to remember. Geometric sequence, right? And the type of sequence, right? Just a little bit different because you have to find a common ratio. It's not that hard though, because you just use the second term divided by the first term, and the formula is a sub n equals the first time r to the n minus 1. That's just what you need to know. Oh.
Limit of the sequence is the value the sequence approaches as the number of terms goes to infinity. If such a limit exists, the sequence is called convergent, and a sequence that does not convergent is said to be divergent. Here is a symbol for limit as the terms go to infinity. The LIM sign and the below of it represent the limit formula. AN represents the formula of the terms. Now, we are going to graph this sequence. Each number in the sequence is called a term. Determine the x-axis for the term of the sequence and y-axis for the number given in that term. For example, the coordinate of 1/2 would be at x equals 1 and y equals 1/2. So after graphing all the coordinates, we're gonna connect them and we get a line. We can see that the graph keeps going. It doesn't come to any exact y-axis, or is it approaching infinity. So it is considered that a divergent sequence, which means that it fails to converge to an infinite limit. Now, look at this graph. The first term of the sequence is 2.67. Then after that term, the points come closer to x-axis or y equals 0 line. At this time, the y-axis is 0.09, and if we stretch the graph and look for 100 term, we can see that it's come even closer to y equals 0 line. So it means it converges to the number 0. Therefore, we call this sequence a convergent sequence because it converges to 0. However, it does not need to be only 0. It can be any number on the y-axis depending on where the line goes. Now, let's type 4 simple examples. Example number 1. If the formula of n term equals 2, it means that a sub 1 is 2, a sub 2 is 2, a sub 3 is 2, and a sub 4 is also 2. So it means that the limit of this equation equals 2 and it is a convergent sequence. So when we plot the point in and connect them, we will get an exact horizontal line at y equal 2. Example number 2. Now, if the n term equals negative 3 times n, after plotting in the graph, we will see that the graph keeps going down without any exact y-axis value, so it is considered that a divergent sequence. Example number 3. 1 over n plus 1. When we plug the number of the term in for n, we will get this graph. We can see that it converges to 1. So it's considered a convergent sequence that converges to 1. Example number 4. Put the sequence negative 1 to the n. Let's plug in for n. When you plug in 1, you get a negative 1. When you plug in 2, you get 1. When you plug in 3, you get a negative 1. As you can see, there are only two numbers that exactly exist this sequence, which are negative 1 and 1. So, when you plot it in the graph, you will get a switching order, which means that you are not approaching any exact number. So, this is a divergent sequence.
The limit of a sequence is the value the sequence approaches as the number of terms does to the infinity. If such a limit exists, the sequence is called convergent, and a sequence that does not converge is said to be divergent. Remember when the line horizontal is converging. Remember if it's swinging, it's divergent. If it keeps going up, if it keeps going down, that's divergent for sure.
Here are some theories of limit you should have remembered. Number 1. A limit can either have one limit value or none. Number 2. Limit of c as n approaches infinity equals to c. Number 3. Limit of c as n approaches infinity times a equals to c times limit of a as n approaches infinity, which equals to c times a. In this case, a represents limit of a as n approaches infinity. Number 4. Limit of a plus minus b as n approaches infinity equals limit of a as n approaches infinity plus or minus limit of b as n approaches infinity, which equals to a plus minus b. Now, number 5. Limit of an times bn as n approaches infinity equals to limit of an as n approaches infinity times limit of bn as n approaches infinity, which is a times b. Now, number 6. Limit of an over bn as n approaches infinity equals to limit of an as a approaches infinity and limit of bn as a approaches infinity equals to a over b. And b shouldn't be 0, because if it's 0, we can't find that value. Number 7. Limit of an to the k as n approaches infinity. You'll get a limit of an as n approaches infinity overall to the k, so you get a to the k. In this case, you can move between them. Number 8. Limit of square root an as n approaches infinity will equal to square root limit of an as n approaches infinity, which equals to square root a. And number 9. Limit of absolute an as n approaches infinity equals to absolute of limit of an as n approaches infinity, which is absolute A. Just 9 of them might sound a lot, but if you can remember some of them, you can relate them all together. So for example, if limit of an as n approaches infinity equals to 10, then what is limit of 6 times an as n approaches infinity? At this case, you can do like the theories that already said, that you can move between them. So limit of 6 times an as n approaches to infinity, you can move 6 into the front and time with the limit. So you get 6 times limit of an as n approaches infinity. So you know that limit of an as n approaches infinity equals to 10. So substitute it and you'll get 6 times 10, which equals to 60. Now let's try another example. If limit of an as n approaches infinity equals to 3 and limit of bn as n approaches infinity equals to 5, then what is limit of an plus bn as n approaches infinity? So if this is given, you know you can separate them from each other. So you get limit of an as n approaches infinity plus limit of bn as n approaches infinity. So just substitute them in and you get 3 plus 5, which equals to 8. That's your answer. Now from this example, you see that the plus sign, you can separate them from each other. It's mostly the same to the minus, to the multiple, and to the divide, that you can separate them from each other and do their own way to find the answer. So if you remember one of it, you should be able to solve either of it. For theory number 10, we have 2 of them. So 10.1 is limit of n to the k as n approaches infinity will always equals to infinity, but k has to be a real number. So as you can see, when n to the 1 or n to the 2, it keeps going to infinity even more faster. As you can see, the k is increasing. The line even go to the infinity a lot faster. And for 10.2 is limit of c over n to the k as n approaches infinity will always equal to 0, as c is a constant number. Theory number 11. If c is a constant number and limit of f of n as n approaches infinity equals to infinity, or limit of f of n as n approaches infinity equals to negative infinity, you'll get limit of c over f of n as n approaches infinity equals to 0. So for example, in this case, limit of 5 over 3n as n approaches infinity will equals to 0, as 5 represents the c or a constant number and 3n represents the f of n or the function under. So when you substitute or you plug in for the n, you find out that the first term of this sequence is 5 over 3 times 1. You get 1.67. For the second term, you get 5 over 3 times 2. You get 0.84. And the third term is 5 over 3 times 3. You get 0.56. So you can see that it is converted to 0. Now, theory number 12 is just like a quick trick for you. So if c is a constant number and n is a positive constant, so if negative 1 is less than c, and c is less than 1, you get that limit of c to the n as n approaches infinity will equals to 0, which means the c has to be a fraction number. So if it's a fraction to the n, you will always get a 0, which means it's convert to 0. So when we plug in the number, for example, if limit of 1/2 to the n as n approaches infinity, now you plug in the number and you get the first term 1/2, the second term 1/4, the third term 1/8. Now you can see it is coming closer to 0. But what about if c is greater than 1 and limit of c to the n as n approaches infinity? You will get a and infinity, or you can't find the value. So for example, limit of 5 to the n. As n approaches infinity, you will get infinity. So when you plug in the number for n, you will see that first term is 5, the second term is 5 to the 2, so it's 25, and third term 5 to the 3, it's 125, and 5 to the 4, it's 625. So it keeps going. So this is a divergent, and you can't find the value. What about c is less than -1, which means c is a negative number? You will get that limit of c to the n. As n approaches infinity, you can't find that value for real. So for example, if limit of -2 to the n, as n approaches infinity, when you plug in the number, you will see that it keeps swinging to the positive side and to the negative side, so you can't find any exact value at all. So in this case, you will say that it can't find value. And here is 4 another special cases to find the limit. It's actually a special tips for you. So first, to find a polynomial. Second, polynomial fractions. Third, exponential. Fourth, square root. Let's go over it together. I'll begin with saying that if it's a polynomial, the limit is always infinity or can't find value. So compute the limits of polynomial. Given a sub n equals to 5 times n to the 4 plus 2 times n squared minus 6n plus 3, you put the limit symbol for 2 of them, and then you separate them all in their own limit symbol. And then you can use the theories that was in the first page of the theory section and clarify all of it. So for the first one, 5 times limit of n to the 4 as n approaches infinity, you'll get n times infinity. As you know, n to the 4 is always infinity because it keeps going, plus 2 times limit n to the 2 as n approaches infinity. You will get that 2 times infinity. It's almost the same as the 5 one, and 6 also. And 3, limit of 3 as n approaches infinity is 3. So at the end, you get infinity plus infinity minus infinity plus 3. So it's all infinity. You know that it keeps going to anywhere. So you can't find any exact value of this. Second, compute the limits of fractal polynomial. Given a of n equals to 5 times n squared plus 3 over 2 times n squared plus n minus 4. So first thing first, you have to divide them all with the variable that has the most power, which means n to the 2 is the most variable to the power. So you divide it all by n to the 2 and put it in the front. So now you can cross them out in the front, and what you're left with, it's there. Now, remember the formula or the theory that said limit of a over n to the k equals to 0. So you know it's 0, you can just cross it out. Now you're left with limit of 5 as n approaches infinity over limit of 2 as n approaches infinity. So you'll get 5 over 2. And that's your answer. Now the third one, compute the limit of exponential. So given a of n equals to 1 over 3 to the 2 minus n. So separate the bottom first. So you get 1 over 3 to the 2 times 3 to the n. So you know that 3 to the 2 is 9. So substitute 9 in it. And 3 to the negative n. If it's a negative, you can move to the top. As the same, if it's a negative at the top, you can move to the bottom and get the regular one without the negative. So you get 1 times 3 to the n over 9. So put the limit in, and you get limit of 1 over 9 as n approaches infinity times limit of 3 to the n as n approaches infinity. As you know, you can move the 1/9 to the front and time with the limit of 3 to the n as n approaches infinity. You know that 3 to the n is an infinity from the theory at the right side. So if one of it is infinity, you know that it's gonna be infinity. So for this question, you can't find the value, and it is a divergent. Now, the last special case, compute the limits of root. So given a of n equals to square root 1/9 times n to the 4 minus 18 times n squared plus 9. So put the limit sign for two of them, and then you know that if the square root is in the equation, you can put the square root in the front of the limit of all of them, and just solve the inside first. So as you see, also the same step as always, and at the end you will get square root of 1/9 times infinity minus 18 times infinity plus 9. So it's times infinity. You know that if it's infinity, it's always infinity. So you will actually get square root of infinity. But yeah, of course, you can't find the value. So it's also a divergent one. Moving on to the next. What about the sum of infinite series? You will know the value or not depending on if it's a convergent or divergent series. Now look at this series. You can see that it is adding up by a different number. So let's make it a line to see how much it goes. So 1/2 plus 1/4 plus 1/8 and keep adding up. But you know that it will never reach 1. So this means that this series convert to 1, which means it will never be at exact 1. So the formula for the infinite sum is s to the infinity, or the summation to the infinity, equals to sigma a of n, which equals to limit of s of n as n approaches infinity. Just for a reminder, here is the formula for arithmetic series that you will use in this section. Now let's solve the problem. If 2 plus 6 plus 10 and keep plus till we know that the formula of this series is 4n plus 2. Is this arithmetic series a convergent series or a divergent series? So as we know, the formula to find the infinite sum is equals to limit of Sn as n approaches infinity. So we know that Sn equals n over 2 times a1 plus an. So we will substitute the number in. So we know that a1, or the first term, is 2, and we know that the n term is 4n minus 2. So substitute that in, and you will get that S infinity equals to limit of n over 2 times 4n as n approaches infinity. So calculate them, and you'll get 2 times limit to n squared as n approaches infinity. So you get 2 times infinity. As it is a infinity, you always can't find that value. So this is a divergent series. Another reminder of the formula for a geometric series. We have learned this before, but just a reminder because we will be using it also in this section. Now, let's solve this problem. Is this geometric series a convergent series or a divergent series? So, by the way, how do you know it's a geometric series? So, when you compare the term, you can see that each term is different from each other by a common ratio, which is 1/10. So, let's go over it. So the formula for the infinite sum is equals to limit of Sn as n approaches infinity. In this case, for formula for Sn, you know that r is less than 1, which is 1/10. So you use this formula. So you substitute all the things that are given in and calculate it, and you will get limit of 1/9 as n approaches infinity minus limit of 1 over 9 times 10 to the n as n approaches infinity. So you get 1/9 minus 1/9 times 0. So 1/9 minus 0 equals 1/9. So it is a convergent series. However, there is an easier way to solve that problem here. If you know that r is less than 1, you can use this formula instead. Infinite sum equals to first term over 1 minus r. But you have to make sure that absolute r is less than 1. So we show you some proof here that how does it work. Now let's solve this problem again, but use that easier formula. So the formula is infinite sum equals to first term over 1 minus r. You know that r is 1/10 and the first term is 1/10. So substitute the number in and you'll get 1/10 over 9/10, which is equal to 1/9. See, it's the same number, but you have to make sure that this formula will only work if absolute r is less than 1. What if r is something that is greater than 1? For example, like this series, 3 plus 9 plus 27. So you see that r is equals to 9 over 3, which is equal to 3. So we have to use this formula instead because r is greater than 1. So substitute all the things in and calculate it. Now you get 3/2 times limit of 3 to the n over 2 as n approaches infinity minus limit of 3/2 as n approaches infinity. So you get something infinity in the equation, which is 3/2 times infinity. So it's gonna be infinity as always. So this one, you can't find the value and it is a divergent series. Make it simpler, we put it in the line. So 3 plus 9 plus 27 plus 81. You can see that it keeps going to infinity, or it is getting bigger. So if absolute value of r is greater or equal to 1, you will see that it is considered a divergent series. However, if you put a series that have an absolute value of r less than 1 into a line, for example like this one, 16 plus 12 plus 9, you will see that it will approach one number. So this is considered a convergent series. Now let's solve it in formula. So the series is 16 plus 12 plus 9 and plus plus plus. So you know that absolute value of r is less than 1. So you have to use this formula, which is kind of easy, right? So we know that r is the second term divided by the first term. So you get 12 divided by 16. So your r is 3/4. And your first term is 16. So just substitute them in. So you will get 16 over 1/4, which is equals to 64. And that's your answer, which means it converts to 64. Here's your conclusion for geometric series. When absolute value of r is less than 1, the sum of the series will be convergent. But if absolute value of r is greater than or equal to 1, the sum of the series will be divergent.
Sum of infinite series, it equals limit of Sn as n approaches infinity. There's two types of series, arithmetic and geometric. Please remember it.
So imagine you have the interval 0 to 1, and you cut this interval at 9, 10, and 110. And for the most right piece, you cut that piece at the 9, 100, and 1, 100. And so you keep cutting this on and on and on up to infinity. So as you continue cutting, you trend to converge to 1. So now you can say 0.999 on and on and on up to infinity equal 1. This is one of our examples.
After we know all the things we just learned, let's apply it. So given 6.43 with a little dot at above, so express the following recurring decimal as fractions. So a little dot on the number means that number is being repeated. So this is equal to 6.43333. And let's separate it into their own decimal place. So you get 6 plus 0.4 plus 0.03 and keep going. And convert this into that fraction. So you get 6.4 plus 3 hundredths and keep going with that. So you can see that the 3 at the above is a geometric series. So you know that if it's a geometric series, you can find the r with it. So put the second term of it, which is 3 over 1000, divided by 3 over 100, which means you get a common ratio that is 1/10. So as you know, if we get this, we have a formula for the absolute value of r less than 1, which is the first term divided by 1 minus r equals infinite sum. So we use this formula into this problem. So bring the 6 plus 4/10 down because we didn't do anything with that. And then let's use the formula for the 3 groups. So calculate it and substitute the number in. You will get 193 over 30 at the end, and that's your answer for the decimal place 6.43 with a dot at above. Express the following recurring decimal as fractions. So given 6.435, 3 with a little dot above and 5 with a little dot above, a little dot means that that number is being repeated. So 6.435 with a little dot at 3 and 5 will equals to 6.4353535 because it has to be repeated. So after you get that decimal, let's separate it into their own number. So 6 plus 0.4 plus 0.03. Now let's make it into a fraction on their own. So 6 plus 4/10 and whatever. So as you can see, we make 3 grouped together and 5 grouped together. As now you can see, it is a geometric series because it has a common ratio which is 100. So this is a geometric series. So remember, if a geometric series that have a absolute value of r less than 1, you can use this formula to find infinite sum. So let's apply that into the equation. So now you get 6 plus 4/10 because you didn't do anything with it, and then the 3 groups, and then the 5 group. Now calculate it and you will get 6 plus 4/10 plus 133 plus 198. So you get 6,371 over 990 as your answer.
So you have the square, and the side of this square has length 1. And if you connect the middle point of each side of the square, you will have a new square. And if you continue keep doing this on and on and on up to infinity, the question is, what is the sum of all the perimeter of the square?
Thank you for watching us to the end. Now you can solve problems about limit. Hope this video is helpful for you. Thank you so much. ขอบคุณค่ะ